Can't you see that it's just raining? It ain't no.
Last week, I gave a lesson on Stewart's theorem, but nobody listened. It's my own fault. I used PowerPoint. PowerPoint is boring. People learn in a lot of different ways. Experience is the best teacher. That is why I have simulated the perfect real-life situation. Today, Stewart's theorem is gonna save birthdays.
10 minutes!
I like me. For the 4th year in a row, we're celebrating Michael's 40th birthday.
Attention, attention, party planning committee! Last week I watched Judge Judy. Now every day I want to implement a new court ritual into my daily office proceedings. Tinker Toys, Judge's best friend. Our first order of business is how do we coordinate the party without inviting Phyllis? I mean, come on, she's dropped the ball for our PPC. She's not even here.
Michael, I'm right here.
I object. Our second order of business is how to make this year's 40th birthday party more exciting than last year's 40th birthday party.
Let's cut the cake into triangles.
The jury's verdict? Guilty of a good idea.
I will now measure out 2 and only 2 sides of this triangle, making it absolutely necessary to find the third side using Stewart's theorem.
Okay, so I'm gonna draw this part in. Oops. Is that good? Okay, should I change? For me? Close enough. It's not coming out. Oh, wait. Got it. Okay.
It's time to cut the cake. Oh my god, it seems as though we must cut the cake using the sides of the triangle outlined for us. How are we going to find the third side?
Just use a ruler to measure it. That's why they call me the boss.
There are no rulers. Gasp, how could that be? Quick, use the surge of fear and adrenaline to sharpen your math deductive skills.
Attention, intention, employees of Dunder Mifflin. I have created the perfect plan to solve this crisis. The first person to solve for the missing side will be rewarded by receiving the largest piece of cake. Quick, all hands in. Break on triangle. 1, 2, triangle!
You're done?
Eureka! This theorem that just popped into my head gives a relationship between the 3 sides of a triangle, 1, 2, 3, and a side dropped from the vertex to any other side of the triangle. Could you stop it? Okay. As you can see here, this is side C, side B, side A, and x plus y equals A. Hold on. The general equation for this theorem is AP squared equals B squared times x plus C squared times y minus A times x times y. Because we have all the sides we need to know, this side of the cake is 8, and this is a 45, 45, 90 degree triangle, so you know this has to be 8 root 2. And because this is 8 and this is 8, x plus y has to be equal to 16, and this side 3 was already given to us. All you do is plug in the numbers and you get that the unknown side is about 9.434 inches. And I can prove that I have come up with this with my own proof. Here I've redrawn the triangle with the same sides labeled the same way. Except this time we're going to call this point right here point P. This is point A, point B, point C. Because this is a straight line, you know that angle APB plus angle APC has to equal 180 degrees. And using log cosines, you know that B squared has to equal this side P squared plus Y squared minus 2py cosine of theta. This here being theta. And then using law of cosines again for this triangle, knowing that this angle is supplementary to that angle, you have c squared equals p squared plus x squared plus 2px cosine of theta. Then if we move over here, multiply the first equation by x, which I already did, and then you multiply the second equation by y. And then if you add the two equations, you get the general form of Stewart's theorem, and you can replace anything that's x plus y with the letter a, because obviously from over here you know that x plus y equals a, and then you have the theorem that we used previously to get the answer. ap squared equals b squared x plus c squared y minus axy. And ladies and gentlemen, I call this stroke of genius the Michael Scott theorem.
This is an outrage. That's not Michael Scott's theorem, that's the Stewart's theorem.
Dwight, let me explain something to you. I make the rules and you listen to them blindly, okay? And if you have a problem with that, you can bring it up with our complaint department. It's a trash can!
We can give a fire safety talk.
Phyllis, it doesn't look like you're doing your math homework. If you do your math homework, you might get extra credit, maybe even an A.
We're not even in school.
To the dean!